Hi, welcome to this session on Mathematics, Chapter 2 on Polynomials for Class 10, Grade 10. We are doing division algorithm for polynomials, exercise 2.4, question number 1. Question number 1 states, verify that the numbers given alongside of the cubic polynomials below are their zeros. Also verify the relationship between the zeros and the coefficients in each case. Let's solve the question number 1, part 1. We are given the polynomial and let's denote it by px. That px is equal to 2x cubed plus x square minus 5x plus 2. And we are also given the number 1 by 2. So let's verify that if 1 by 2 is a zero of this polynomial or not. So p half will be equal to 2 times 1 by 2 raised to power 3, that is this value here, plus half square minus 5 multiplied by half plus 2. Once simplified, this makes px is equal to 0, and since this is equal to 0, the 1 by 2 is a zero of this given polynomial. So second step is that we will verify that if 1 is 0 of this polynomial. So we find the value of p1, that is when x is equal to 1, and we get that p1 is equal to 0. Hence 1 is a 0 of this given polynomial. Now let's verify if minus 2 is a 0 of this polynomial. When we keep x is equal to minus 2, we get the value of the polynomial is equal to 0. Hence we can say that minus 2 is a 0 of the given polynomial. Therefore, by now we have verified that 1 by 2, 1 and minus 2 are zeros of the given polynomial. For the next step, let's denote these three zeros by letters alpha, beta and gamma respectively. Also, we notice that the given polynomial is of the cubic form ax cubed plus bx squared plus cx plus d, where a is equal to 2, b is equal to 1, c is equal to minus 5 and d is equal to 2. So now let's go to the next step of verifying the relationships. But what is the relationship? What is the relationship between zeros of the cubic polynomial and its coefficients? So this equation alpha plus beta plus gamma is equal to minus b by a is the relationship, and now we shall verify it by using the values of the zeros that we found out. That is, we found out or we verified that alpha, beta and gamma are equal to 1 by 2, 1 and minus 2. So now we shall place these values of alpha, beta and gamma into the left hand side of this relationship that we are trying to verify, and then whatever value we get, we will compare it to the right hand side where we will keep the values of a, b and c, which we have just written over here. So let's try to verify the relationship number 1. We see that alpha plus beta plus gamma is equal to 1 by 2 plus 1 plus minus 2, which is equal to minus 1 by 2, which indeed is equal to minus b by a. Therefore, we can say that we have verified the first relationship. The second relationship is alpha beta plus beta gamma plus alpha gamma is equal to c by a. So now let's use the values of alpha, beta and gamma that we verified just now into the left hand side, and we get by this the value of alpha beta plus beta gamma plus alpha gamma is equal to minus 5 by 2, and which we see is indeed equal to c by a when we use the values of c and a from here. So we can say that this relationship has been verified as well. The third relationship is alpha multiplied by beta multiplied by gamma is equal to minus d by a. Now let's use the values that we just verified for the alpha, beta and gamma, and we notice that alpha, beta and gamma is equal to minus 1, which indeed is equal to minus d by a. Hence we can say that we have verified the relationship number 3 also. So in summary, we can say that the relationship between zeros and the coefficients of the given polynomial has been verified. Now let's do the question number 1, part number 2. We are given this polynomial and we have to first verify if that these three numbers are its zeros or not, and then we shall verify the relationship between the zeros and the coefficients of this polynomial. So we denote the given polynomial by px equal to x cubed minus 4x squared plus 5x minus 2. And let's first verify if 2 is a 0 of this polynomial. We see that value p2 is equal to 0. Therefore, 2 is a 0 of this polynomial. Next, let's try to see if 1 is a 0 of this polynomial, because 1 is another number given to us. So we put this x is equal to 1 and we see p1 is equal to 0. Hence 1 is a 0 of this given polynomial also. So by now we have verified that the numbers 2, 1 and 1 are the zeros of the given polynomial. And now let's denote them by alpha, beta and gamma respectively. Also, we notice that the given polynomial is of the form ax cube plus bx square plus cx plus d, and we can say that in this given polynomial a is equal to 1, b is equal to minus 4, c is equal to 5 and d is equal to minus 2. Therefore, alpha plus beta plus gamma, from the given zeros we know that this is equal to 2 plus 1 which is equal to 4, and this indeed is equal to minus b by a, because b is equal to minus 4 and a is equal to 1. Similarly, alpha beta plus beta gamma plus alpha gamma is equal to 5, which is actually equal to c by a. Similarly, alpha multiplied by beta multiplied by gamma is equal to 2, which is equal to minus d by a when we use the values that we have found here. So we can say that we have verified the relationship between the zeros and the coefficients of the given polynomial.